Hi Bio1. Today we're going to talk about the nitrogen cycle. So the first thing that's important to know is that our atmosphere is made up of 80% nitrogen, and that's in a gas form of N2. There's some important things about nitrogen. There's some interesting things is that plants can use two types of nitrogen. They can use ammonia, which is NH4+, and they can use nitrate, which is NO3-. And they also can use some organic forms that you can find in amino acids and other things as well. Now, the really cool thing is that bacteria can use not only the ammonium and the nitrate, but they can also use nitrite, which is NO2-. So bacteria here help us to be able to use nitrogen in appropriate ways. Now, animals can only use organic forms. So this ammonium, nitrate, and nitrite that you see previously cannot be used by animals. Okay, so let's get started on the nitrogen cycle. We have a few different ways that N2 is converted in order for us to use it. The first way, the way that you probably learn about in ag class sometimes, is nitrogen fixation, which is where that's the most common way that nitrogen enters the ecosystem, and it's the conversion of the N2 gas that we have up here by bacteria into ways that can be used and changed into organic forms that we can use. So we have nitrogen fixing bacteria that is in the root nodules of legumes. We also have a nitrogen fixing bacteria that can be down here in the soil. The next thing that happens to it from there is if we're going to take this route and we're going to go from the beans, we would have like a whole nother step here where it can go into decomposers, like this mushroom. And that's our decomposer. So the decomposers actually have a bacteria with them that can allow them to change the nitrogen into NH4+. So you go from here to here. We can also have another step where we have like a dog or an animal that can also then use its waste products to go into the mushrooms or into the decomposers. If, however, we don't do this part, so if we skip this, and the nitrogen goes through fixating from the soil bacteria, it goes from N2, it can't switch right to NH4+. So the next stage it's going to have is NH3, and this is called ammonification. So during ammonification, it's going to change from NH3 to NH4+, which, as we saw previously, is ammonia. Now, the decomposers are going to also convert it into NH4+. The next thing that can happen from here is this can be used by plants. So we can have all of these plants here. I'm going to draw one right here that's going to make you think of a plant. So it can be used by these plants. Now the process of using that, and then the plants will then go back into decomposers, is called assimilation. Okay, so from NH4 down here, we are now going to go into something called nitrifying bacteria. And there's actually two steps that could have nitrifying bacteria. We're only going to have one drawing for them today. So from nitrifying bacteria, it goes from the ammonium through the nitrifying bacteria. That changes it to NO2-. Then it's going to go through nitrifying bacteria again, and it can be changed into NO3-. Then what happens next is that group can then go through denitrifying bacteria, which is going to change the NO3 minus into N2. So this is the basic way of how this works. So to go over it again, we have legumes. Those are like beans. They've got nitrogen fixing bacteria in their root nodules. Now, that goes through nitrogen fixation, or we can do that with soil as well. Now, that is then going to turn it, if we go through soil, into NH3 in a process called ammonification. If it didn't go through that step, it's going to kind of stop that step. It's going to go all the way over here to the decomposers. They're going to change it into NH4. Ammonification happened here, which changed this group into NH4 as well. The next thing that we're going to have happen is that NH4, the ammonium, could be used up here in plants. Then it could, if the plants get eaten by this or this, that could then cause them to, of course, urinate out more ammonium, which is going to then put it back into decomposers, which is going to put it back into this. Now, from the NH4, we have nitrifying bacteria that is going to allow it to change into NO2 minus. NO2 minus is going to have nitrifying bacteria again that is going to change it into NO3 minus. That's going to convert it with denitrifying bacteria into N2, which is the way that we can use it in our atmosphere. So how does this matter to us? One ways that this matters is you all know that right about this time of year we have a whole bunch of tractors driving around, and the back of the tractors are pulling these tanks. And they look like white tanks like this. And you will see a sign on them that says caution ammonia or caution NH4+. So what they're doing is they're spraying, so this is my spray, they're spraying all of the fields with ammonia. Now, one of the issues that happens as a result of this is we can end up with too much ammonia. And ammonia is really good for plants. So nitrogen and nitrogen fertilizers are really good to get plants to grow. The problem we have is if too much of it gets put on the field, or it's put on the field at the wrong time, you can see what's going to happen. There's a little bit of a slope here. All of this ammonia is going to go into this water. Now that water is then going to either go into the ground, and then we can use some of our nitrogen fixing bacteria to kind of mess around with it, or it's going to be runoff. Now the issue with the runoff is that that is then going to go into the ocean. So around the Gulf of Mexico, all of this ammonia is going to gather, and that's going to cause an algal bloom. In the algal bloom, we're going to have a whole bunch of growth in the water. That growth is later then going to be a problem because after all of that stuff dies, when it has used up all of the nitrogen, we're then going to have a problem with there's going to be what's called a dead zone. So we know about the dead zone, and that gets a lot of media attention and things. But the next thing I'm wondering for your challenge question today is how does nitrogen runoff influence our river and stream life in our area? So do we have dead zones around here due to nitrogen? Also, another question that a lot of people wonder is why are we putting so much nitrogen into the soils? Well, we've found over time that if some nitrogen is going to run off, we're going to want to use others to make sure that those plants have what they need. So that's what I've got for the nitrogen cycle. Next, we're going to talk about how the nitrogen cycle works in your biosphere. So I drew a biosphere here today for you, so it's a little bit better than what I had started with. Now, in this case, I have a bean plant or a legume. I don't necessarily need that. I could have a regular flower. Things will just run the way that we talked about earlier, where it'll go straight into the nitrogen fixing soil bacteria, and then you'll have ammonification happen. So, first off, we have N2 up here. Because if our atmosphere is 80% nitrogen, I'm pretty sure you got some in your jar as you started. So, the next thing is I have nitrogen fixing bacteria attached to my bean plant in the roots. Now, that is then going to go into a decomposer, because as I was making my whole thing, I realized that, oh, here we go, there's our decomposers. I realized that I had a bit of a problem because I ended up with some fungus and things growing, and those are going to work as my decomposers. So if I go from my legume, well, actually from the atmosphere to my legume, the legume is then going to go into the decomposers. That's going to change it into NH4+. Then we're going to run with some nitrifying bacteria, which I have here. So we're going to pretend like those are over here. The nitrifying bacteria is then going to change it to NO2-. Then I'm going to have some more nitrifying bacteria here. It's going to change it to NO3-. And then I'm going to have denitrifying bacteria up here. Now all this should be inside of my jar, but it doesn't all fit. So you can go to the edges if you need to as well. Now the next thing we have is we have this assimilation system. So I've got this flower right here. This flower is going to use what it can, then it's going to be sent into decomposers. And we're going to continue this whole process. If you have any questions about this, be sure to let me know. Hope you guys have a good day. Bye.